So, today we're talking about evaluating functions, something that should be reviewed for the most part. Right? So first and foremost, the formal definition for a function, right? Those fill in the blanks at the top of your paper. A function relates each element of a set with exactly one element of another set. Keywords there are exactly one. Right? If I have x values, if I have a function, they relate to exactly one y value. So if I plug 3 in for x, it should only come out to be one y value. It shouldn't come out to be 2 sometimes and -3 other times. Right? So if I plug one thing in, each element is related to exactly one element in a different set. Just in time for start our notes. So if you look at the picture here, the diagram, I'm starting in that x set, right? That set of x's. Each x value that I have in there should correlate to exactly one y value. Now, multiple of these x values can be the same y. You notice these should go to the same. That's perfectly okay. However, one x cannot go to two different y's. Or one element cannot go to two different elements. Does that make sense? So if you look at the bottom one down here, why is this one not a function? If you look in here, why is that not a function?
5 goes to 3 different y's.
5 goes to 3 different y's, right? We said all the x's can only go to one y. Now 4 and 5 can go to the same one, but 5 cannot go to 3 different y's. That's like saying, hey, I'm going to plug 5 in for x, and sometimes I'm going to get 4, sometimes I'm going to get 5, sometimes I'm going to get 7. Does that work in a function? No, right? We don't know any function we can plug that into. So that's the big thing, is they map to exactly one other element. Okay? Cool? This is saying the same thing. So, how can we tell a function by the graph? That second part, we use what we call the vertical line test. So the vertical line test is, just like it sounds, you draw a vertical line on your graph. It crosses no more than one time if it's a function. Right? So, the technical definition, on a graph that you have a single value means that no vertical line would ever cross more than one value. Because the idea is, guys, this is one x value. Right? This is like, let's say x equals 3. If it hits more than once, that means it has 2 different y values it can come out to. So that's not a function on there. That one up there is not a function. If you do the vertical line test, it should hit only once. If it hits more than once, it is not a function. Because then it's mapping to multiple y's. Alright? Okay. Any questions so far? Alright. Then let's talk about actually figuring some functions out. So evaluating. Am I going too fast?
Can you just go back real quick?
Yeah. Yeah, no problem. Good? Okay, sweet. So, evaluating linear functions. If we have a function that's represented by f of x equals 2x plus 5, and I want to find f of 3, how could I do that?
Plug 3 in for x.
Plug 3 in for x, right? So f of x is basically just a fancy way of saying y equals. But f of 3, so normally it's f of x. What this is telling me is I want x to equal 3. So I'm going to take 3 and I'm going to plug it in for x. So 2 times 3 plus 5. What's 2 times 3? 6 plus 5 is 11. So that equals 11. F of 3 is 11. Well, if we have a function represented by f of x equals -6 minus 4, I want to find f of 1/2. What am I going to do with 1/2?
Plug in x.
Plug it in for x. -6 times 1/2 minus 4. -6 times 1/2, or -6 divided by 2? -3. Minus 4 is -7. So f of 1/2 then would be -7. Well, what about if it says we have g of x equals 2/3 x plus 10. But now we want to find x when g of x equals 7.
Set the equation equal to 70.
Set your equation equals 70, right? If g of x equals 70, I can replace this g of x with 7. So I'm going to get 70 equals, on this side of my equation, 2/3 x plus 10. Well, it wants to know what x is, so I'm going to solve for x. Subtract the 10. 60 equals 2/3 x. Can we divide by 2/3? Do we divide by fraction? Multiply by the reciprocal. Right? So yeah, the right idea normally here is to divide, right? But we don't really divide by fractions. Instead, we're multiplying by the reciprocal. So multiply by 3/2. Or if you want to go ahead and just multiply by 3 and then divide by 2 after that, that works as well. It creates an extra step. But you can do it that way as well. So 60 times 3/2 should be 90 equals x. And that would go right on my line. Alright. Does that make sense? Those 3 problems we just did. And it should be review at this point. Okay? Well, there's a graphing portion over here too, with linear graphs. Hey guys, do you ever notice the word linear relates to things that make a straight line?
It says line.
It says line right in it. Who would have thought? It's crazy. So, it wants me to find f of 2, but it wants me to find it off of the graph. Let's think about it though. If I had asked you f of 2 over here, what would you have done with it?
Plug the 2 into the x.
Plug 2 in for x. So I'm going to do the same sort of thing with my graph. I'm going to let x equal 2. I want to know, when x equals 2, what does y equal? And that's going to be my answer. So let's look at our graph. When x is 2, find where it hits our graph here. It's actually right here. What's the y value there?
0.
0. So it equals
0.
0. F of 2 is 0. Same sort of thing for f of -1. I'm going to let x equal -1. Well, where x is -1, look for where it hits your graph. And it's going to be, what value? What's y at that point? -6, I think. So -6. Good. That's not so bad, is it?
No.
Well, let's think about the other one then. Find x. So x is my question mark. When f of x equals 6. Well, remember at the beginning of this slide, I said f of x is a fancy way of writing what? Y, right? So I'm going to let y equal 6. So now I'm looking where y equals 6. I'm looking to see what is my x value. Well, in this case, my x value would be 5. At that point. All right. Does that make sense?
Yes.
Yeah. Okay. Should we try some absolute value ones? Yes. Good answer. All right. You guys have any absolute value functions?
No.
F of x equals absolute value of 2x minus 4. Find f of 3. We're not going to change anything here. We're going to plug 3 in for x. So absolute value of 2 times 3 minus 4. Now remember, we can't take the absolute value until we have one number in there. Right? So we do all of our operations inside the absolute value first. 2 times 3 is? So absolute value of 6 minus 4.
2.
Right? 6 minus 4 is 2. So absolute value of 2 is?
2.
2. Right? The distance from 0. Absolute value is the distance from 0. In other words, it's always the positive value of what's inside of it. Okay, let's try another one. Negative absolute value of x plus 7. Find g of 2. Same thing. Take 2, plug it in for x. So negative absolute value of 2 plus 7. Well, look at my absolute value. I have one number in there, right? So I'm going to take the absolute value of it. What is the absolute value of 2? 2. Now this negative still stays with, it's not inside the absolute value. So it's negative 2 plus 7. 5. Good. Oh, the next one's my favorite one all day.
Based on how?
It's actually one that we've done already this year. Are you guys remember when we solved the absolute values earlier this year?
No.
Well, we did, semester 1. Well, I didn't with you, but you did with Mr. Siebert.
No, dude.
I guarantee it.
Put it in first.
Okay, let's look at it. H of x equals the absolute value of 3x minus 5. If h of x equals 16, what are the values of x? Well, how did we start this one last time?
Set
So-
it to 1 equal to.
Or set it equal.
Yeah, set it equal to 16, right? H of x equals 16. So I'm going to do that. 16 equals absolute value of 3x minus 5. Well, remember, when we're solving for an absolute value, we got to get that absolute value all by itself first. So I'm going to add 5 to both sides. 21 equals the absolute value of 3x. Does anyone remember what we do from here? Can I just divide by 3 at this point? No. How do we get it so we can get rid of those absolute values? Does anyone remember?
Make another one negative.
Make another one negative, right? I'm going to split it into 2 different equations here. I'm going to make 21 equals 3x. I'm going to make negative 21 equals 3x. Remember, we do that because whether 3x equals 21, the absolute value of 21 is 21. If 3x equals negative 21, what's the absolute value of negative 21? Positive 21, right? So either way, if whether it equals negative or positive, once I throw it in here, it's going to be 21. So that's why we split it up. We split it into 2 equations and we solve both of them. Divide by 3. X equals 7. Or divide by 3. X equals negative 7. Those are my 2 answers. That is review. And that should be refreshing our memories a little bit. Okay, we have another graphing part. You ready for it? Who thinks they can tell me what G of 4 is? Sim, you got it? Are you using your hand or no?
No, why is it 4?
Why is it or?
Yeah.
Because can it equal 7 and negative 7 at the same time?
No.
No, it'd be one or the other. Okay. Who can tell me what G of 4 is?
2.
What?
2.
2. How'd you get that, Baker?
Did on the x-axis 4 and then up to the
Perfect, right? Where x equals 4, we're going to know what y equals. So we find where x is 4, find it on our graph, y is 2 at that point. Good. What about G of 0? Olivia, what'd you get?
2.
2, same thing. Where x equals 0. Go to it, find where it's on our graph, y is 2 at that point. Ooh, what about G of x equals 6?
Equal to y.
What's that?
Equal to y.
Y is going to equal 6, right? Good. Well, where y is 6, what's my x values on my graph?
Negative 4.
Negative 4 and 8.
Negative 4 and 8, right? Or negative 4 or 8, technically, right? So, what is x? Negative 4, I'm just put a comma there for now. Negative 4 or 8, right? It can be either of those. Where x or where y is 6, it hits twice. So I have 2 values for x. Is that a function then? If I have 2 values for x for that y, is that a function?
No.
Why not?
Yeah.
Do you need both negative 4 and 8, or we don't answer good?
Need both of them. Hey, does it pass the vertical line test?
Oh, yeah.
Yeah, remember vertical's going up and down. We said if you want to test if it's a function, draw vertical lines. Right? Now you don't have to do all of them, but I just like to do that. Because if it hits anywhere more than once, it's not a function. Does it ever hit more than once with those somewhat vertical lines? No, right? It always only hits once, so yes, it is a function. Right? We said multiple x's can go to the same y, but the same x cannot go to multiple y's. We don't have that. We're good. All right? Does that make sense? Do we have any questions? Yes, Grace.
When you did if the thing equals 6, what is x? How did you get -4?
So when we're looking where y equals 6, so that hits our graph right here at -4 and over here at 8, okay?
Okay.
Good question. Any other questions? Okay, we have one problem left. Real world example. So we're talking about the growth rate of Bermuda grass. Given by the function 5.9x plus 3.25, where f of x is the total height, that might be important, in inches, x days after initial measurement. So f of x represents our total height, x equals the number of days. How tall is the sample after 3 days? What do you think we should do? Iman?
Never mind, I forgot already.
Never mind, okay. What do we think we should do?
Plug in 3 for x.
Plug 3 in for x, right? It says x is the number of days, so if I know it's 3 days, I'm going to plug it in for x. 5.9 times 3 plus 3.25. So throw that puppy in your calculator. Let me know what we get.
20.95.
What'd you get?
20.95.
Thank you, I'm hard of hearing sometimes. 20.95 inches. Good, alright. So then I'm going to ask, the term 3.25 in the function represents the height of the grass when it was initially measured. The sample is how many times as tall after 3 days. So it started here, ended here. How many times taller is it now?
6.44.
What's that?
6.44 times.
How'd you get that?
I divided 20.95 by 3.
Beautiful. Divide it, right? If I take what it is now, and I divide it by what it started at, I should get how many times taller it is now, right? What'd you say it was, Iman?
6.44.
6.44? Perfect. If you want to write times taller, that's fine as well. You don't have to. And then our last part of the problem here. If the Bermuda grass is 50.45 inches tall, how many days has it been since it was last cut? Well, let's think about it. What represents how tall the grass is? Or in other words, its total height? F of x. So 50.54 is equal to f of x. So what should I do with it? Plug it in, right?
Yeah.
If I know this is the same as f of x, I'm going to plug it in for f of x. So 50.45 equals 5.9x plus 3.25. Well, and then I'm going to find my x value. So it wants to know how many days. X is how many days.
3.
So subtract 3.25. She had 47.20 equals 5.9x. What's my last step got to be? Divide by 5.9.
8.
X equals 8 days. It has been 8 days since they cut the grass. In other words, way too long. All right. Any questions on that? All right. We have one more day of new learning this unit, which is tomorrow. Which means Wednesday is a review day. Thursday is our assessment. We're assessing this Thursday. I'm not going to.
Yeah.
Andrew, you lying to me?
I don't know. I losing guess.
Yes, sir. All right, swipe up, subscribe.